Okay, this is lesson 3.4, be mindful of the fees. And it's all about using percents. So in this lesson, we will calculate simple interest, calculate the percent of increase, calculate the percent of decrease, calculate discount of base price, calculate tax on a purchase, and calculate depreciate. The key terms are listed here. You need to make sure that you update your vocabulary, the last set of vocabulary that I gave you, and include these words in there. Credit cards are plastic cards that act as money. Generally, the credit card company will guarantee the purchase of an item based on a promise that the person is making the purchase will pay the credit card company back, with the possibility of a charge and other fees being added to the purchase. It is a system that has been used or in use since the late 1800s, but has changed dramatically over the years. Why do you think credit card companies take the risk of paying for a purchase for its customers up front? Why do you think people use credit cards instead of cash? Well, in thinking about this, people use credit cards instead of cash because maybe they don't have enough cash to pay for whatever they're trying to purchase. And credit card companies would take that risk because they're going to get some what's called interest off of the money as well. So the longer the people borrow the money, the more they're paying for borrowing that money on top of what they owe the credit card company for whatever it is they purchased. So it really makes sense for the credit card companies to let people borrow that money because they're making money because of it. So that brings us to problem 1, which is all about simple interest. When you save money in a bank savings account, the bank pays you money each year and adds it to your account. This additional money is interest, and it's added to bank accounts because banks routinely use your money for other financial projects. They then pay interest for the money they borrow from you. An original amount of money in your account is called the principal. So, however much money you put in your bank account to start with is your principal. Interest is calculated as a percent of the principal. One type of interest is simple interest, which is a fixed percent of the principal. Simple interest is paid over a specific period of time, either twice a year or once a year. For example, and the formula here is for simple interest. The I represents interest earned, as indicated here. The P stands for the principal in dollars. That's what you start with. The interest rate is the percentage of whatever it is, the interest rate percentage, whatever your bank establishes for that. And then the T is the amount of money earned. I'm sorry, the time that the money earns interest. So how long has that money been sitting there? And so you're simply going to multiply, if you can still see these multiplication symbols, your amount of money that you start with by the interest rate the bank and you decide upon when you put your money in that bank account, and then the amount of time that it's sitting there. And that total is going to be the interest that you earn in dollars. So let's go ahead and look at an example. So Kim deposits $300 into a savings account at a simple interest rate of 5% per year. So that 5% is a number that your bank and you will come up with together, or that your bank is going to offer you. Okay. So this is not, it's not always 5%. This is just an example of what it could be. So you can use the formula to calculate the interest she will have earned at the end of 3 years. So we take our principal, which is the amount of money she started with. In this case, it's $300. Multiply by our rate. Well, you take that 5%, and I'm hoping at this point you can figure out that 5% as a decimal. You always want to multiply that by the decimal form. So 5% as a decimal is 0.05. That's where that came from. It's just the 5% that was established up here. And then the amount of time in years is 3 years. So you just multiply the 3 together, and you can see that Kim will have earned $45 in interest after that 3-year time period. So Complete the table by using your knowledge of the formula for simple interest. So basically we are taking our principal, we are multiplying by the interest rate, the percentage that we're going to convert into a decimal form, and multiply by the years to get our interest earned. So for this one, we would take 425, we would multiply by 0.07, which is 7% as a decimal, and we're going to multiply by 5 years. So once I multiply across here, 425, I'm just going to write over here what I've done so we can see that. And that is going to equal $148.75 for a total. I want you to go down the chart, do the same thing we did. Take your principal, multiply by your percentage as a decimal, and multiply by the time, and that's going to give you this one. I want you to do that and then come back and check yourself. Okay, hopefully you did those pretty easily. Now, this next problem is a little bit different. That's why I stopped, because we're going to talk about this different kind of problem. We know that, and I'm just going to write this on here for you. We have the principal times our interest rate percentage, which is represented by R, and we also have the time frame, and all of that's going to equal our interest. Okay, so for this one we don't have the principal, so we're just going to put the P. We have the interest rate, which is 0.04, and we have the time frame, which is 3 years, and we also have what our total is going to be, which is 30. So now you're going to solve this like you would any other equation that we've talked about this year. So we have 0.04 times 3, okay, which is 0.12. Okay, then if it were written like this, like what you're used to seeing it written like, you could see that we just simply divide by our coefficient of 0.12, and then that's going to give us a principal of 250. So this one's actually 250. The next one is the same kind of thing. This time we have principal, which is 456. We have an interest rate of 6%, which is 0.06 as a decimal. We just don't have the time frame, but we have the interest earned in dollars, which is 109.44. And it doesn't look like that's going to fit for me, so let's So this time you're going to do exactly the same thing, and you're going to multiply these two with 456 times 0.06 gives me 27.36, and T is what we don't know. Remembering that you don't need this multiplication symbol in between. This means the same thing. So, and then here's our 109.44. And we're going to simply divide by 27.36 to get our total, which is 4. So we know that it was 4 years. I want you to try that last one, see if you can figure it out. This time they leave off the interest rate. So see if you can figure that out, and then come back and make sure you've done it correctly. And there you go, there's your answer. The key with this is just to try to figure out what you're missing, and then the commutative property of multiplication says that we can multiply these in any order and it doesn't change the answer. So that's why I was able to do the 500 times 4 to get 2,000, and then 2,000 times r is just 2,000r, which is what I wrote right here. So, and then when you divide those, that gives you the 0.06, which is 6%. In the same way that banks pay you interest when they use your money for financial projects, you too pay interest as well. So when you borrow money from a bank, the bank or the amount you borrow is the principal, and you pay the interest on that money back to the bank. So complete the table shown. So principal here is the amount you borrowed from the bank. The interest rate is the interest rate at which you borrowed. A great example of this would be like you buying a house. Most people do not have the amount of money it takes to buy a house when they go to buy the house. So therefore they have to borrow the amount of money, and then they pay interest on the money based on how fast they pay the money back. But anyway, for now, this is the amount of money that you borrowed. This is the interest rate at which you borrow it. This is how many years. And then this will be the total amount of interest paid. So you follow the same process. We're going to do 5,000 times 6%, which is 0.06, times 10 years, and that's going to give me this total of $3,000. So go ahead and calculate those. You use the same ideas for this as we used in the table before, so you should be able to do that last one as well. I'm going to put the answers, and you need to come check yourself. So there are your answers. Come and see me if you still need some help with that. So problem 2 is about percent increases and decreases. You've used percents in many different situations, including tips, interest, and for construction projects. You can also use percents to describe a change in quantities. A percent increase occurs when the new amount is greater than the original amount. Think about the word increase. It's getting higher. So the new amount is greater than the original amount, then that's what a percent increase is. An example of that is when a store marks up the price they pay for an item in order to make a greater profit. For instance, this jewelry store marks up its prices so it can maximize its profits. What is the percent increase for each of these items? Use the formula shown to complete the table. So, you know, the price that a jeweler pays for a ring or a necklace is not the price you pay. They're going to pay a certain price, then they're going to mark that price up so that you have to pay more than they paid for that so that they can make a profit off of that. If you think about it, it makes a lot of sense. And that's true for not just jewelry stores, but any sort of retail store. The formula or equation that you use in order to figure out what the percent increase is, meaning like how much they marked up the price, is this. So we have the amount of the increase over the original amount, and that's going to tell you how much it marks it up. So let's try to use that to fill in this table. So the first thing we're going to do is we're going to find the difference in dollars that from the cost that the jeweler paid for it and then the customer's price. Meaning when I went out, I'm a store owner, and this is what I bought the ring for, and then this is what I'm going to put it on the shelf in one of those glass cases. This is how much I'm going to sell it for. So there's a difference in those prices. The difference is what we're going to put here. So the difference between 60 and 90 is 30. Here's an ID bracelet. We have the difference here is 120. We have between 25 and then 50, that's 25 difference. And then the last one is a difference of 9. Now, in order to find the percent increase, which is what we're going to do here, we're going to take the amount of increase and put it over the original. So the amount of increase is like the difference in dollars. So how much did we increase the price? So this first one would be 30 over the original amount was 60. So 30 over 60, I hope you're thinking to yourself, oh, that's 0.5. So it's 50%. So they had a percent increase of 50%. The next one, we have 120, which is the difference, or how much they increased the price from when they bought it to when they sold it. And then that over the original cost, which is equal to 1, or 100%. So they increased the price of that ID bracelet by 100%. I want you to do the next two and then come back and check yourself. So there's your answers to the last two. Hopefully you're feeling okay about this. let's move on to percent decrease. Percent decrease is exactly the opposite of percent increase. So a percent decrease occurs when the new amount is less than the original amount. An example of a percent decrease is the value of a car depreciating by 10% per year. So depreciation is the decrease in value of an item over time. So you should know that a car is going to lose value as it gets older and older. So cars depreciate at different rates depending on the demand for the type of car and the condition in which the car is kept. Use the formula shown in the table or to complete the table. So here we are. It's the same kind of thing as percent increase, only percent decrease is amount it decreases over the original amount. Instead of the amount it increases, it's just the amount it decreases. So let's look at the dollars. The difference in dollars. So the difference between 20,000 and 15,000 is 5,000. The difference here in 18 and 16 would be 2,000. The difference between 25,000 and 20,000, 5,000. And the last one is 3,000. So in order to get this percent decrease, I'm going to do the amount of decrease over the original amount. So however much we decreased, we have 5,000 here. And the original price in dollars is 20,000. So this one was a 25% decrease. I want you to go ahead and figure the rest of those out and come back and check yourself. So essentially you are calculating these exactly the same way. You're just having to look at, did my cost go down from where I started, or did it go up from where I started? And that's how you know whether it's a percent increase or a percent decrease. Is the money getting, is it getting bigger, or am I lowering the amount of money I have, or the amount of anything? And that's what helps you to see the difference. So I basically just explained exactly what number 3 is. If the original price or cost is less than the selling price or value, it is a percent increase. And if the original price or cost is greater than the selling price or value, it is a percent decrease. So I want you to think about and come up with some answers for 3, 4, and 5. Number 4, how would you describe a 100% increase? Well, if you look up here, the ones that are 100%, it is simply the new number is double the original amount. So the new number right here is double the original amount. 25 times 2 is 50, and 120 times 2 is 240. That's how you know it's a 100% increase, is if the new price or new value is double the original. And then how would you describe a 50% decrease? If the new number is half of the original amount. If the new number is half of the original amount. I'm not sure if we have one like that. So the new number is half of the original amount. So go ahead and write some things down for these and come back and look at it. Okay, so make sure you have something to the something like this as for your answers. Okay, number 6. Jake was doing a great job at work, so his boss gave him a 20% raise. But then he started coming to work late and missing days, so his boss gave him a 20% pay cut. Jake said, "That's okay, at least I'm back to where I started." Do you think that Jake is correct in thinking he is making the same amount of money when he received a pay cut? If you agree, explain why he's correct. If you do not agree, explain to Jake what is incorrect with his thinking and determine what percent of his salary, original salary, he's now making. Okay, so if we think about this problem, we're gonna have Jake make 100. Thinking about just his pay is $100. So if we increase, if you get a 20% raise, he's gonna raise his amount that he makes from 100 to 120. Because that is a 20% raise off of 100. Because if we took 0.2 times 100, that would give us 20, and then 20 plus the original 100 he made would be 120 total. So we're going to think about him. He now makes 120. Well, if he gets a 20% decrease off of his pay, then now he's going to be making 80% of what he did make, because a 20% decrease would be him only making 80% of what he made to begin with. Because if we have 100, he was making 100% of what he was making, and then he took 20% off of that, he's now making 80% of what he was making. So 80% of that is 0.8. So here's what he was making, which is $20 more than he was, 20% more than he was making. So it's 120 times 80% of this, because now he's only making 80% of what he was making, and that is 96. So now he's actually at 4% less than what he was originally. So you should disagree, because now he is making less, 4% less. He is now making 4% less than he was originally. All right, last but not least, we have problem 3. Some things gain and some things lose. So generally things like homes and savings account gain value or appreciate over time. Other things like cars depreciate every year. New cars depreciate about 12% of their value each year. So we're going to look at these different amounts and try to figure out how much the car would depreciate for that year. So the first one, it says 12%. So we're going to take that 12% and we're going to create a decimal, which is 0.12. And we're going to simply multiply by each one of these values to see how much that car would depreciate. So we're finding 12% of 35,000. And that equals 4,200. So this car in the first year would depreciate 4,200. I want you to go ahead and try the next two and then come back and check. So this car would depreciate $5,400, and this in the first year, this car would depreciate $2,400 in the first year. If a car lost $3,600 in depreciation in the first year, what was the original cost of this car? Well, just like in the last problem, we have the cost of a car, C, original amount, and then we multiply that by the percent it would depreciate. So I'm going to go ahead and put this car depreciate percent, and then that's going to equal amount, the amount it depreciates, amount depreciated. Okay, so we're going to use that same thought here. So we do not have the original amount, so we're going to use C. We're going to multiply that by the percent the car would depreciate in the first year. So we are going to use the decimal form of that like we've been using. And then we have that it lost $3,600. So from here we would simply divide by 0.12, because if rewritten, it would be 0.12 C, because remember, I can change the order. Community property says I can switch the order and it's not going to change the answer. That's why I know that I'm just dividing by 0.12. Okay, you got to do that on both sides. And 3,600 divided by 0.12 gives me 30,000. So the car would have originally been priced $30,000. Okay. Complete the table to record the value of a car that costs $50,000 that depreciates at the rate of 12% per year for the first 5 years. So for this, we're going to actually have to do one step at a time. So the first step, we're going to take $50,000. We're going to multiply by 0.12. It gives us 6,000. So I'm going to take the 50,000 for the original. We're going to subtract the 6,000 to get 44,000. So now this car costs $44,000. We're going to take that new price. We're going to multiply by 0.12. That's going to give us 5,280. We now have to take the 44,000. We're going to subtract this to get the new price of 38,720. And we're going to continue this process till I get the table filled in. So that would cover that first 5 years. So go ahead and do that and then come back and check. So hopefully you were able to get that. I kind of stopped showing work here, but you just follow that same process. You take the new price, multiply by 12%, and then subtract it back off and go to the next one. And the last part of this is just to create a graph of the data. So go ahead and plot those points. There should be 6 of them starting with the origin, and then come back and check. My apologies. It's not starting at the origin. It's starting at 0, 50,000. Okay, so it should look something like this, and then it says, would it make sense to connect the points on the graph? If so, connect them and explain your reasoning. I'm going to let you think about that, and then I want you to tell a friend to come and tell me what you think about that, because I don't want to give you that answer. The first person to do this and give me the correct answer, you and your friend, will get a piece of candy. This last question, describe how the value of the car decreases over time. The value decreases the most the first year and then decreases a little less each year after that, each following year after that. So you are now finished. You may go ahead and do any of the skills practice.